Good afternoon, everyone. Good afternoon again to the OGs who were logged in earlier. So if you're just logging in, you're obviously not going to have time to do the do now. So you're just going to have to buckle in and go along for the ride. We're going to start with question 2 first, and then we'll go back up to number 1. So these are questions to help review Chapter 5, where we talked about the periodic table, periodic trends, noble gas configuration, valence electrons, all that sort of stuff. So we're going to start with question 2. Predict which element in each of the following pairs has the lower ionization energy. So for A, is it rubidium or cesium? Which one has lower ionization energy? So we've got some contention. Let's talk about what the trend is. For ionization energy, as you go from the top of a group to the bottom of a group, or actually, I think I taught it the opposite way, so let me. Because I believe that's the way that you have in your notes. So as you go from the bottom of a group to the top of a group, your ionization energy increases. And as you go from left to right across a period, same deal. Ionization energy increases. So for A, rubidium and cesium are both in the same group. So the one with the lower ionization energy is going to be the one that's closest to the bottom. That's going to be cesium. What about B? Which one has lower ionization energy? Sulfur or chlorine? Yeah, it looks like we're agreeing on that one. It's going to be sulfur. So sulfur and chlorine are in the same period. And sulfur comes first. So that means it's going to have a lower ionization energy than chlorine. This is the type of question you're going to have to be able to answer on an exam, like the one you'll have next week. Now we're going to go over question number 1. So we kind of left off on the topic of ions, writing their configurations, and this idea of isoelectronic. Remember that isoelectronic means the same number of electrons. So what we're saying here is which one of these choices does not have the same number of electrons as krypton. Let's look at a periodic table. I'm trying to circle everything that I put here for options. So we have ions of all of these, and we're trying to see which one has the same number of electrons as krypton and which one doesn't. Yeah, you can go ahead and put your answer in if you have an answer or a guess. It's zinc. So the way that you can tell very quickly without writing out any electron configurations is figuring out if you were writing the noble gas configuration for these different ions. We had zinc 2+, strontium 2+, selenium 2-, bromine minus. If I were writing noble gas configurations for these ions, which noble gas would I use? Selenium and bromine, they're both going to gain electrons, right? We're not going to use argon for that one. That's why it's krypton. They have the same number as krypton. They're going to gain electrons to look like the noble gas in their period. So selenium gains 2 electrons and it's going to look like krypton. Bromine gains 1 electron. It's going to look like krypton. Strontium, however, and I'll do that in a different color. Strontium is a metal, so it's going to lose electrons. That's how it forms its ion. And it's going to look like the noble gas in the previous period. Strontium is here. So the previous period would be the one above it. Whoops. Not trying to go back that far or go forward. So the previous period is the one above it, and the noble gas is krypton. Zinc is also going to lose electrons. So when it loses electrons, it's going to lose the 4s electrons. And it's going to look like argon. So that's a review kind of what we did in the last several minutes of our last class. Ooh, that scared me for a second. Okay. We're back. This is a review of what we did with the last class. And I know that the ions are something that were a little bit difficult. If you don't understand the ion portion, then chapter 6 will be a little bit more difficult for you. So make sure that you understand how to form ions, that metals lose electrons, nonmetals gain electrons, because that is the basis for what we're doing in chapter 6. So are there any questions on either of these do-nows? So let me circle the answer here. Any questions? All right. Okay, go for it. You could just put krypton in brackets and call it a day. All right, that was a good question. Today we're going over chapter 6, which is the language of chemistry. We're going to be talking about classifying inorganic compounds and acids, classifying ions, naming things, and writing chemical formulas. So again, the ions need to be something that you understand. And we're going to go over it again. But if it's something that eludes you, you need to make sure to let me know. So office hours tomorrow from 2 to 4, or set up an individual appointment. Because like I said, you have an exam next week and it covers chapters 5 and 6. So you don't want to be behind. We're going to start with the classification of compounds. We're only going to be talking about inorganic compounds and acids here. The 3 major categories we're going to cover are ionic, molecular, and aqueous acids. This is a very good flowchart to have in your notebook. 2 reasons why. 1, it helps you kind of place the types of compounds and gives you the broader picture. 2, I'm going to write down the abbreviations that I use throughout this lecture so that you know what I'm talking about. Because if I had to write 3 or 4 words every time I was trying to talk about the classification of a compound, we'd be here all day. So make sure that you write down what these abbreviations mean that I'm about to write in your notebook so you can reference that as we're going along. Under the major category of ionic compounds, we've got binary ionic compounds, which I'll abbreviate BIC, and ternary ionic compounds, TIC. So those are the 2 types of ionic compounds we'll cover today. We have 1 type of molecular compound that we're going to cover, and that's the binary molecular compounds, BMC. The 3rd major category is aqueous acids. Binary acids, BA. Ternary oxyacids, TOA. So I'll give you a minute so you can get this down in your notes. And then I'll check back with you to make sure that you're ready to move on. So I'm serious. Take a screenshot, do something. Make sure that you have this, because I don't want you to be like, wait, what's that again? No, we don't have time. So make sure it's in your notes. Are we ready to move forward, or do you need another second or 2? All right, let's go. So these are the 5 classes that we're going to talk about. In the YouTube video, I go in detail for each of these 5 classes. For today's lecture, I'm just going to give you the nuts and bolts, just the bare bones, so that we can go on and do some examples. So you're definitely going to want to watch the YouTube video to make sure you get all the information. Because this is the drive-through, okay? You're hungry. It's 11 p.m. You're like, what's open? Cookout. So you go and you get a quesadilla. That's what this is, okay? The first class is binary ionic. A binary ionic compound is going to be made of 2 elements. This is also something you're going to want to write down because it's going to help you with classifying compounds. Those 2 elements are 1 metal plus 1 nonmetal. And an example of that would be NaCl, that's table salt. Na, that's sodium, it's the metal. Cl is chlorine, that's the nonmetal. Anytime that you see the word binary, you should think 2. So these are all hints for how to classify compounds. 2 elements, think binary. Ternary ionic compounds have 3 elements. They typically have 1 metal plus 2 nonmetals. I realized I misspelled that. Struggle, y'all. Can't write today. So typically it'll be 1 metal plus 2 nonmetals. The other way that we can define this, which will make more sense once we get to the ions portion, is that you have 1 metal plus 1 polyatomic anion. So write that down, but don't worry about it yet. An example of a ternary ionic compound would be NaNO3. So that's sodium nitrate. There is a metal, and this whole unit is a polyatomic anion, which is made of 2 nonmetals. The third class is binary molecular compounds. Again, we see the word binary, so we think 2. There are 2 elements. In this case, you have 2 nonmetals. And an example of that is water. Hydrogen and oxygen are both nonmetals. Fourth class is binary acid. It's also going to have 2 elements. It's always going to have a hydrogen, and that hydrogen will be first. It will be followed by a nonmetal. And then in parentheses, you'll see AQ, which stands for aqueous. That's a binary acid. Ternary oxyacid has 3 elements. Just like the binary acid, it will always start with a hydrogen. It will be combined with a polyatomic anion, which again will make more sense once we cover the classes of ions. And it will also have that AQ. So an example of a binary acid would be HCl. That's a component of your stomach acid, so hydrochloric acid. And an example of a ternary oxyacid would be HClO3. So that's chloric acid. And you'll learn how to name these things. So I was purposefully trying to write slowly so that you can write it down too. Do you need more time to get this down in your notes, or are you ready to move on? Yes, for more time? All right, we'll give another like 30 seconds, and hopefully you can finish up in that time. Because the next thing we're going to do is move on to practicing classifying these things. So if you don't have this information in your notebook and you didn't watch it on YouTube already, you won't be able to participate. So that's why I'm stressing that you get this in your notebook. All right. Now we're going to practice. I'm going to walk you through the method that I use for classifying compounds. So it's asking yourself some questions so that you can narrow down the class of compound you're looking at. The first thing I do is look at how many elements I have. In this case, we've got CO2. That's 2 elements. Already I know it's got to be some class that's a binary something or other because of the 2. Carbon and oxygen are both nonmetals. So that tells me even more. I've got 2 elements. They're both nonmetals. Look at your notes. What's the only thing that carbon dioxide can be? 2 elements, they're both nonmetals, and you can use those abbreviations. What do you think CO2 is? Some of y'all are fast. I'm going to try to give a few extra seconds of grace. So I agree. It's a binary molecular compound because those have 2 elements and they're both nonmetals. Let's do the next one. How many elements do you see in this compound in B? I was hoping someone would say 3. So we're looking at the type. So there's 1 magnesium and there's one fluorine, right? We have multiple fluorine atoms, but that's okay. There's only 2 elements here. We're not looking at the subscripts. How many metals do we have? So you jumping ahead of me. We've got 1 metal plus 1 non-metal, right? Since we've got 2 things, it's okay. I like it when you understand. You're excited. That's good. You've got 1 non-metal, 1 metal, total of 2 elements. So it's got to be something binary. The only thing that's got 1 and 1 is the binary ionic compound. I'm going to give you 2 minutes, and I want you to try to classify the remaining 3 on the page. We'll have more practice with classifying as we go along. But right now, I just want you to give these a shot, and I'll check back in 2 minutes. So what did we get for C? C is a ternary oxyacid. It starts with that hydrogen, and then we've got the aqueous at the end. Since you don't quite know what a polyatomic anion is yet, you know it's not just 1 nonmetal. We've got 2 nonmetals in here. So it's got to be the other one. It's got to be the TOA. What about D? This one's a binary acid. You have the hydrogen plus the nonmetal. And E, what did we get for that? It's a ternary ionic compound. We've got that metal plus the two nonmetals. So if you didn't get those, it just takes practice. So you're going to want to commit to memory the different compound types, the classes, and what they're made of. So binary molecular has two nonmetals. Binary ionic has one metal, one nonmetal. You're going to need to know that so that you can classify. Any questions so far, or are we good to move on? So I am posting, I don't remember if I posted it already. I did in my other section. I have some practice for you. So it's a worksheet that you classify, and then you write the chemical formula or the name. So I'm going to have more practice for you in addition to the Chapter 6 check-in and your Chapter 6 homework for mastering chemistry. So if you need more practice, you can do that. Now we're going to move on to classifying ions. We talked about ions. We didn't give any formal names to positive ions or negative ions, but we did talk about what electrons are lost, the valence electrons, and what that looks like. So we're going to do a little bit of a refresher of the end of Chapter 5. If any of the things that I say are a review are completely new to you, you need to review Chapter 5. So ions can be broken up into two categories, cations and anions. Cations are the positive ions. The only things that make positive ions, we're talking about metals here. So metals form cations. Anions are negatively charged ions. In general, we're talking about nonmetals. Each of these categories can be broken down into monoatomic ions and polyatomic ions. Monoatomic means one atom. So your cation or your anion is just one atom with a charge. Polyatomic means two or more atoms. So it's a group of atoms that have a charge. We're going to talk about each of these for cations and anions. Now for polyatomic cations, there's only one, and that's the ammonium ion. So we're not going to spend time on that, but I will bring it up when we look at a chart of all the polyatomic ions. This is another good flowchart to have in your notes. So we're going to go over each of these categories one by one, so you can make your flowchart along the way. We're going to start with the monoatomic cations. The first couple of things are review. Metal atoms lose their valence electrons to form cations. That's review. The group number, and we're talking about, sure, I can go back. Yeah, you can always let me know, like, hey, whoa, I'm not done. Let me know when you're ready. Okay. Starting with monoatomic cations. We're talking about metal atoms. They lose their valence electrons to form a positive ion called a cation. The group number for the representative elements, so the ones with the A behind it, that group number is going to tell you the ionic charge. So if we were talking about sodium, sodium is in group 1A, so its charge would be 1 plus. That should be review. Naming cations is new. To name a monoatomic cation, you simply take the name for the parent atom and then you write the word ion. So for calcium 2 plus, you write calcium followed by the word ion. Done. How would you name this second cation? It is the lithium ion. So that it's simple as that for naming monoatomic cations. But this is only for the representative elements. We've got a lot more metals than that. The metals that are in the D block, the transition metals, a lot of them can form multiple cations. So when we're writing out a name of a compound, we have to include what charge that metal is. I'm glad y'all taking notes. I'll pause a little bit longer on the end of each slide to make sure we're ready. Okay. So we talked about the representative elements in those metals. Now we have to address the transition metals. Transition metals oftentimes can form multiple cations, and you have to indicate which cation you're forming when you're writing the name of a chemical. For that, we're going to use a Roman numeral that follows the name of the parent ion, and that's called the stock system. Some exceptions. So these are transition metals that only form one ion. That's zinc, silver, and cadmium. They only form one ion. So for those, we do not use the stock system. All the other transition metals, key here being transition metals, we use the stock system. So I'll show you what that means. Fe is iron. Iron is a transition metal. Because of that, it can have multiple charges. So we're going to write 3 as a Roman numeral in parentheses, directly following the name of the element, followed by the word iron. Ion. It's too close together. Now, just in case you don't know your Roman numerals, I'll put some up. You shouldn't need more than this. So those are Roman numerals 1 through 6. You should not need more than that. How would you name this cation, Hg2+? You look up Hg, figure out that's mercury, and it's a transition metal. It's not one of our exceptions, so we're going to indicate the charge using the Roman numeral 2, followed by the word ion. Now I bring up mercury because it is a special case. The other charge that it can have is +1. However, you're not going to see this. Mercury has some issues. It likes to be partnered up all the time. So this is the mercury 1 ion. There are 2 mercury atoms that each have a +1 charge for a total of 2+. So this is an exception. It's a little funky. And I wanted to introduce that to you because you may come across it in your homework, on the quiz, and on your exam. Don't want to have any surprises for you. Sure. So mercury 1, normally we would write it like this, with the mercury and then the plus sign. But that's not actually how it occurs in nature. There are actually 2 mercury 1 ions together, making the charge 2+. But this is actually how you write the mercury 1 ion. You have 2 mercury 1 ions coming together to form this particular compound. So are we ready to move on? So I want you guys to do some practice. Name these ions. I'm not telling you whether or not it's a transition metal or not, whether it's an exception or not. So you need to look at the periodic table and figure out whether it's a transition metal or not, and how to name it, whether you need to use the stock system. I'm going to give you 3 minutes. Write it down in your notes. And this is just, I made a typo that I forgot to correct. So CS, it should be plus for its charge, not 2+. So I'll give you 2 minutes and then I'll check back in. How we doing? What did we get for the first one? So this first one, cesium, it is not a transition metal. So that means we don't have to use the stock system. Remember, the only reason we need the stock system is if something can have multiple ionic charges. Cesium cannot. So it is just the cesium ion. What about the second one? So zinc is a transition metal, but it's an exception. It's an exception. It can only form one ionic charge. So we don't have to use the stock system for this one either. What about the third one? So chromium, Cr, that is a transition metal. It's not one of our exceptions, so we have to use the stock system. It is the chromium 2 ion. So how do we feel about that? So we'll need some more practice for sure. And you'll get more practice. Good. As long as the concept makes sense, with practice you'll be good to go. Now we're jumping over to anions. We're going to start with the monoatomic anions. The part I'm about to say should be review. Nonmetals gain valence electrons to form anions, which are the negatively charged ions. To figure out the charge, you can again use the group number. And we're talking about the nonmetals that are in groups 5A through 7A. So if I have a group 5A nonmetal, to figure out the charge, I'm going to take 5, subtract 8, and that would give me -3 for my charge. Again, that should be review. If you feel like you've never heard that before in your life, you need to go back to chapter 5. Naming these monoatomic anions is new. What you're going to do is take the first syllable, which is the root of the name of the element, and then you're going to follow that by IDE. I'll show you what I mean. N3 minus. N, we know that as nitrogen. We're going to keep the first syllable and get rid of the rest of the word. So that root for nitrogen is nitra. replace the rest of that word with IDE, so that what you actually have is nitride, and follow that with the word ion. We have bromine next. I'll start you off here. If we have bromine, we're going to keep the brome. So what will our ion name be if we're getting rid of everything after the BROM? It's going to be bromide. So that's how you name the monoatomic anions. You keep the first syllable, get rid of the rest, replace it with IDE, followed by the word ion. Everybody good on that? With this chapter, there's a lot of memorization of rules, and you have to practice how to apply them. These rules are not difficult, there's just a lot of them. So practice, practice, practice. Now we're getting to those polyatomic anions that I mentioned earlier on, that you'd have no clue what that was until we got to this part, unless you watched the lecture already. Polyatomic anions, which I abbreviate PAA, it's typically one or more elements combined with oxygen. There are some exceptions. They're not all combined with oxygen. The ones that are called oxyanions. Many of these anions have a name that end in ATE. One example would be the nitrate ion. Notice it ends in ATE. But others end in ITE. So NO2 minus is the nitrite ion. Look at these two polyatomic anions. Can you tell me what the one difference is between NO3 minus and NO2 minus? And if you're thinking, this is too simple, it is that. So it's the ite and the ate ending, but there's a difference when you look at the chemical formulas. We've got 3 oxygens with the ATE, and we've got 2 oxygens with the ITE. The ITE form of an ion has 1 less oxygen than the ATE form. But has the same charge. So ATE has 1 more oxygen than the ITE. It's the other way to say it. But both of these ions have the same exact charge. In this case, it's just a 1 minus. That was a little blip. Thanks, Blackboard. So you're going to want to know this bit of information here about the ITE versus the ATE. I'm not going to make you memorize the polyatomic ions. You will get a chart, and I'll show that to you in a minute. But you do want to understand the naming of these oxyanions so that you can understand the naming of the ternary oxyacids when we get to it. So just as a bit of practice, the formula for chlorite is ClO2 minus. What is the formula for the chlorate ion? The chlorate is going to have one more oxygen. So it'll be ClO3, and it has the same charge. So if you could answer that question, then you understand the difference between ATE and ITE when it comes to oxyanions. Are we good on that topic? This is the chart that I was referring to. Common polyatomic ions. There's only one cation, which I mentioned before, and that's the ammonium ion. All the other ones are anions. You will get this chart for your exam as well as the final exam. So you do not need to memorize this. You will get it, but you need to understand how to use it. I've already posted a PDF of this chart in this classroom. So you'll see with shared content, there's a PDF of common polyatomic ions. That's this. If you would like, you can download it, print it out, put it in your notebook, use it with your homework. When I post exam 3, it will be posted in the folder with the exam. So you can print it out from there too. Again, do not memorize this. We're going to go through and talk about classifying and naming binary ionic compounds and ternary ionic compounds. And then around there, we'll probably take a break after we do this part. So remember, with the ionic compounds, we're talking about a metal plus nonmetal. Binary has 1 and 1. Ternary has 1 metal plus usually more than 1 nonmetal. A better way to say that would be a metal plus a polyatomic anion. So one of the anions from the chart that I just showed you. With that said, before we do naming, I want you to classify these two compounds. And you can just write it in the chat. Call that 1, and this is 2. Classify these two compounds. So I agree. The first one is a binary ionic compound. We only see 2 elements there. One's a metal, one's a nonmetal. The second one is a ternary ionic compound. We see a metal, and there's a polyatomic anion there, the SO4. So you'll get familiar with the polyatomic anions just from practicing naming and classifying and things like that. When you're naming an ionic compound, whether it's binary or ternary, you're going to have the cation name first and then the anion name second. So remember how we were naming those monoatomic anions, monoatomic cations and all that? That's where this comes into play. For the first one, we've got two ions. We've got the barium, that's our cation. And we've got the iodine, which is our anion. Ba, that's barium. It is a group 2 metal. Do we need to use the stock system to write the name for the barium ion? No, it's in group 2A. So it's just the barium ion. We don't have to do anything special. Iodine is in group 7A. It's our nonmetal. And we said to write the name of the monoatomic anion we get rid of everything after that first syllable and replace it with IDE. So we would name this the iodide ion. Now we just put them together. And get rid of the word ion from each. So that's naming a binary ionic compound. Questions about that? Then I'm going to move on and show you an example of the ternary ionic compounds. The copper is our cation. Is copper a transition metal? Oh, I had a question. Did you need me to go back over the whole process of naming? We're going to go through pretty much the same exact process to name this ternary ionic compound. So if you can walk with me through this one, and then if you still have a question, we can address it. Is that cool? All right. So we established that copper is a transition metal. Do we need to use the stock system? Yes, we do. So I'm not going to worry about my copper right now because I need to figure out its charge. And the only way that I can do that is by looking at the charge of my anion. Look at your chart and tell me the name of this anion and what its charge is. Again, I posted the chart in the shared content for this class, so it should be there in perpetuity. You use the stock system only with transition metals. And that's if they have more than one ionic charge. So you don't have to try to name SO4. It's on that chart for the polyatomic anions. So its charge is 2 minus, and it's the sulfate ion. Since our sulfate ion has a charge of 2 minus, that means that our cation has to have a total of 2 plus. So it's right next to, when you see the chemical formula for it, the superscript tells you the charge. It's in the chart. So we figured out that our anion is the sulfate ion. Now we're working on the copper. There's 2 copper ions indicated by that 2 there for the subscript. And together, those 2 ions have a charge of +2, which means one of them has a charge of +1. So we have the copper 1 ion. Does everybody follow that? Not really. Okay, let's try that again. Yes. So you're mixing a couple of concepts. So the overall compound has no charge. So all of the cations, the charge from those, plus the charge from the anions, that equals 0. But if we break them apart, if we were to take this compound and break it apart into the cations and the anions, those will have a charge. When we bring them together, they cancel each other out. And because we know that the charges have to cancel each other out, we can figure out the charge of our cation. The sulfate has a charge of 2 minus. In this compound, we've got 2 copper molecules, or 2 copper atoms, excuse me. And that's given by this subscript here. That tells us that we have 2 coppers. And both of those together must have a total charge of +2 to cancel out the -2 from the sulfate ion. Does that part make sense? And don't worry, we'll do more examples. Go ahead. So, again, we're mixing two things together, okay? Here is the whole compound. It is neutral. SO4, that's an ion, and its charge is 2 minus. We've got this copper ion, and we've got 2 of them. Those ions together have a charge of 2 plus, so that when you add these 2 copper ions plus this SO4, we've got positive 2 plus a negative 2, which gives us 0. Does that help? Okay. Since we know that the copper part, the cation part, has to have a total of positive 2 charge, and we have 2 copper ions, each one of them must have a positive 1 charge. So does that last leap make sense? So if it still doesn't make sense, we got to move on because there's a lot more to do. So we still need to put the name together for this. We've got our copper 1 ion, our sulfate ion. We're going to get rid of the word ion and put them together. So the full name is copper 1 sulfate. Yes, there's a hand. Yes. So you're naming the cation first and then the anion. But we had to figure out what charge the copper was because copper can have multiple charges. So I've got a couple that I want you to try. Classify and then try to name these 2 compounds. I will give you 2 minutes and then I'll check in. Let's start with the classification. What kind of compound is this first one? It's a ternary ionic compound. What about the second one? binary ionic. That's right. We'll start with the easier one and work our way up to the harder one. So we'll start with the binary ionic compound first. The K is going to be our cation. Turns out that's potassium. It's in group 1A. Do we need to use the stock system to name this ion? Thank you. I will play chicken. We will sit here. Or if you don't know, you can tell me that you don't know. It's okay. I was asking if we needed to use the stock system to name the ion. So we had potassium. I was asking if we needed to use the stock system. Nope, it's okay. So naming that is easy. It's the potassium ion. Next, we're going to have the anion. And that's sulfur. We're going to get rid of everything that isn't that root and replace it with IDE. It becomes the sulfide ion. Get rid of the word ion. And that's our name, potassium sulfide. So how many of us were able to get that one? By a show of hands, or you can say me. Okay. Good. Now let's do the ternary ionic compound. Calcium is going to be our cation. Is it a transition metal? No. So the way that we name that part is simply the calcium ion. So no stock system here. Then you have to go to that polyatomic ion sheet and look up NO3. And what you'll find is that is the nitrate ion. You get rid of the word ion. It's going to bug me if I don't rewrite that. I'm one of those people. You get rid of the word ion. And you have calcium nitrate. So I think one person got close to this. You have to remember, if you don't need to use the stock system, then there's no need to have any numbers after the cation. So the name of the game is name the cation, name the anion, and then put them together. So do you feel like you have a little bit more understanding than you did before? That's our goal, to go from a large ball of confusion, and hopefully by the end, it's a little bit smaller, or a lot of bit smaller. I'd prefer that. So as long as we're constantly improving, then we're doing it right. Let's get through writing chemical formulas, and then we'll take a break. So we're still on the binary and ternary ionic compounds. This category has the most that we can do with it. The other categories are not as bad, I promise. So just to review, when you have an ionic compound, you have positive ions and negative ions. We said that. The positive ones are cations, the negative ones are anions. The total positive charge in that compound must equal the total negative charge. And we were just talking about that with the stock system and having to figure out the ion name. So to use that example, again, just to make sure that we understand it, this part, that's our cation. We have 2 copper 1 ions. That's what copper 1 looks like. If we have 2 of them, then our total charge is positive 2. SO4, you look up on your chart. It is an anion, and its charge is negative 2. We've only got one of them. When we add up our cation charge, plus the anion charge, it needs to equal 0. So in this case, our total cation charge is plus 2. We've got 2 copper ions times a charge of 1. Our anion charge was negative 2. And that gives us a total charge of 0. So I just wanted to go over that again because I know that was given some trouble. So does that make a little bit more sense than it did before? Good. All right. So I'll show you an example. Here we have the name calcium sulfide. We have to go backwards and figure out what the formula is. We know that when we're writing a name, we're going to have the cation name plus the anion name. So let's deal with the cation first. Since that's the calcium part, if we were to write it out as an ion, it would be the calcium ion. You find calcium on your periodic table, and it's in group 2A. Is it a transition metal or no? So then what is the charge of our calcium ion? It's not a transition metal. How do we figure that out? Yeah. It's 2+. And the reason we know that is because of the group number. Now let's do the anion part. The sulfide ion, this root tells us that it comes from sulfur. Sulfur is in group 6A. What is the charge for the sulfide ion? It should be 2-. And the way we get that, we take the group number, which is 6, and subtract 8. That gives us -2. So we've got our cation and our anion. Doing this color scheme, I hope it's helpful because it takes extra time. If it ain't helpful, I mean, I love colors, but by George. Okay. We've got +2 and -2. When we add that together, we get 0. So that means that we're going to have 1 calcium and 1 sulfur in our chemical formula. You always want to do this step to make sure that if you just put together one of your cation, one of your anion, that you're going to get a net charge of 0. Because if you don't, then you have to do an extra step. And I'll show you that. But does this part make sense? Going from the name to the chemical formula. Good. So what we just did was a binary ionic compound. I'm glad it clicked. So that's how we name the binary ionic compounds. Let's do another one. This time, we have iron, and iron is a transition metal. We're already told what the charge of the ion is because using the stock system, there's a 3 in parentheses. So we don't even have to think about it. We already know that's our cation. Does everybody follow on how I figured out the cation? From the name to writing out the symbol. Good. Now we got to deal with this anion. Are the colors helpful to try to keep the separation of what's what? Okay. Then we're going to keep with it. So we have oxide. From what we know about naming, that first part before the IDE tells us we're looking at oxygen. So ox can only come from one thing. And the nonmetals that we have are pretty few. So you can figure it out. Oxygen is also in group 6A. I'm not going to walk through the charge again because it's exactly the same as the sulfur that we just did. So we know that oxide, it's O2 minus. Now let's do our tally. If we take one cation plus one anion, what do we get? Our cation is +3. The anion is -2. Those are not equal. We have a non-zero answer. So that means that we have to have multiples of something. We've got to have more cations, more anions. We've got to balance this out. What you're looking for is the lowest common denominator. Otherwise abbreviated as LCD. If you remember learning about fractions, which may be a while ago, you're looking for the lowest common denominator. And that means you're looking for the number that both the 3 and the 2, you can use that to divide by and get a whole number. So the lowest common denominator for 3 and 2 is 6. It's the smallest number that both 3 and 2 can be used to divide by. What does that mean? It means that we're going to have multiple irons and multiple oxygens. 3 times what gives you 6? I know it's a simple question. 2. So if we have Fe 3 plus times 2, then we're going to have a charge, a total charge of +6. For our oxygen, oh, we've got a guess. I'm gonna make you wait, see if you got it right. For our oxygen, it's 2 minus. So what times 2 will give you 6? You gotta go 3 there. 3 times 2 gives you 6. So that gives you a total charge of -6. When we write this out, you're going to use those as your subscripts. So Fe2O3. That's kind of the long way to do it. If you had chemistry in high school, yes, I was just going to bring that up. I don't like to show you the cross, until you know what you're doing. So what you're doing, whether you know it or not, is finding the lowest common denominator. Once you figure out your 2 ions, iron 3 plus, oxygen 2 minus, instead of going through all the math like I did, there's a faster way to do it. You take the number for the charge for the anion, and that becomes your subscript for your cation. you take the number in the charge of your cation. That becomes the subscript for your anion. And as long as you don't have any crazy multiples, like if you had 4 and 6 there, that would be a problem. But doing it this way won't lead you astray. So that's the cross method. How do we feel about that? If you understand at least one of those ways, then you're good. Okay. I want you guys to try this one. Then we'll go over it and then we'll take a break. I'll give you 1 minute to get started because I'm looking at the hour. The hour is drawing nigh. If you've been to church a few times, you've heard that before. So I want to make sure that we get through everything. So I'll give you a minute to get started and then I'll get started. Yes, that's it. So let's show how we get there. All right, good job. We've already gone over the calcium ion, so I'm not going to go over that. That's Ca2+. Nitrate, you're going to look up. That's NO3- from your chart. If we do our check to see whether or not we're even or not, that's a no. We've got a non-zero answer there. So that means we've got to do something different. Here I'm just going to show the cross method because that is pretty much what you're going to use. Notice how I put the nitrate in parentheses. We want to, when we're doing this method, make sure that we convey. We want all of the nitrate to be multiplied. So when we take this 2 and put it down here, we want 2 nitrates, not just 2 times 3 oxygens. We want 2 whole nitrates. We don't see anything here except the minus. So that implies 1. You don't typically see a 1 down there like that. So don't write it. This would be your answer. Questions on that? Y'all are just happy because you got it. Ain't no shame in that. Okay. If you do have questions, it's okay. We may not have time to go over it right now in class, but I can do it right after. So if you have a question, you don't feel bold enough to ask it in the group chat, then you can send me a message privately Or you can wait until people leave or are leaving, and you can ask your questions then. So I have one more example. I'm going to go through this one because we're combining the stock system and we've got, the multiples. So you can kind of do it along with me and make sure you understand it. Iron 2, we've seen that before, sort of. So we can go straight from the name to the ion. That means the phosphate part has to be our anion. And since we don't recognize that as an element, it's got to be one of those polyatomic anions. So given that information, what do you think the chemical formula for iron 2 phosphate is? We're going to use that cross method. So there's a 2 that's going to go down there. And again, notice the parentheses. And there you go. So it seems like y'all are getting it. And that makes me happy. That's right, celebrate. So we're going to leave the ionic compounds. We're going to move on to the binary molecular compounds. We're going to name these. Going in reverse is easy, so I'm going to save going in reverse for when we do some overall general practice at the end. So clear your mind of the ionic compounds. Not completely, just push it to the side a little bit. Make a little room. Just as a reminder, the binary molecular compounds have 2 nonmetal elements in them. The first element in the compound is named first. And we use Greek prefixes to tell how many of each element we have. Let's say that this was our compound. The first element is carbon. We have 1 of those. You would think, hey, I should put monocarbon there. You don't. That's the only exception. If there's only 1 of your element, your first element, you don't use mono. You just put the name of the element. The second element here is oxygen. And we have 2 of them. For 2 atoms, you're going to use di. Then you're going to name it kind of like we were doing with the monoatomic anions. You're going to take that first syllable and add IDE. So the name of that molecule is carbon dioxide. I am not going to give you the table of prefixes. Most of these you've already encountered, so you'll just want to know these. And I'll show you some examples. I'm going to ask you some questions along the way to make sure you got it. For this first one, take a second. Yes, I can go back. Let me know when you're ready. See, the time I forget to ask is when y'all are like, wait. My bad, y'all. All right. So this first one, we've got CO. We've got 1 carbon, 1 oxygen. Again, for the first element, you don't use mono if there's only 1. So you just write carbon. For the oxygen part, however, we do need to write a prefix. Notice how there's only 1 O there. That's another little spelling thing, so I chose this one on purpose. You don't want to put this. That's wrong. 2 O's next to each other. One that just looks strange to me, but you just don't do it. So if you have mono along with oxide, you just have 1 O. So that's carbon monoxide. Try to name this second one. Probably took you longer to type it than to know what it was. So we've got 2 nitrogens. Going to use the prefix di. Then just write the element name. We've got 3 oxygens. So we're going to use tri. Write the root, which is ox, followed by IDE. So we good on naming the binary molecular compounds? I'm not going to go through an example where we go from the name to the chemical formula, but you will need to do that. And I have an example of that at the end. So if y'all are good, I'm going to push forward to the binary acids, and then we'll do practice on this at the end. So we're going to move forward to binary acids. As a reminder, your binary acid is going to be a hydrogen plus a nonmetal. And you're going to see that aqueous at the end. The way that we name these, the first word is going to always start with hydro. That's for the hydrogen. Then you're going to put the element stem, which is the same as the root, that first syllable. So for HF, the F is fluorine. We're going to keep the fluor part. That's our stem. Then you add the suffix IC. So the only part that you're modifying for this first word is what I am boxing in red. The hydro and the ic are always there for a binary acid. Then all you have to do is write the word acid. So it's hydrofluoric acid. I'll do that again. Always start with hydro for a binary acid. This time the nonmetal is iodine. We're just going to keep the iode. We follow that with the suffix IC, ic, and write the word acid. Again, the only thing that we modified is what I boxed in red. Is that clear to everybody? This is naming binary acids. Now we're going to do naming ternary oxyacids, and then I have some practice for both of these. Remember, ternary oxyacids always start with the hydrogen, and then you have one of those oxyanions. So we're talking about the polyatomic anions on that chart. Followed by that AQ in parentheses. This is where understanding the ate and the ite comes in handy. If you have an acid that's derived from one of those anions ending in ATE, you're going to change the suffix to ic. So here, we've got NO3. You look that up on your chart. That's the nitrate ion. Since we have an acid derived from that, we're going to get rid of the ATE and replace it with ic. Replace the word ion with acid. So the name is nitric acid. We do something very similar if the ending for the oxyanion is ITE. You look up that anion on your chart. It is the nitrite ion. You're going to replace the ITE with OUS. Replace the word ion with acid. So you have nitrous acid. Are those rules clear for naming the ternary oxyacids? I told you these are easier. So you're also going to need to go in reverse. Yeah, I'll give you a second to write it down. So you're going to need to be able to go in reverse. So when you see the ick, you know that means 8, and you find nitrate. And since it's an acid, you write the hydrogen with the nitrate. And like I said earlier, there's going to be some additional practice for you to classify, name, and write chemical formulas. And I'll post an answer key. Let me know when you're ready to move on. The last slide. So this one, Talia. Okay. I'm sorry, Lydia. I just went straight to this other slide. Were you good on this one? Okay. And this is always posted online too. Since Tuesdays are my long teaching days, it might take me a minute to get it up there, but it'll be up there today. So here's some practice. I'll give you 2 minutes to name these and classify them. So classify them first, and that will tell you which rules you need to name. I'll check in 2 minutes. Let's start with classifying first. There's only 2 options here. So this first one, binary acid or ternary oxyacid. What about the second one? It's a binary acid. And the third one? It's a ternary oxyacid. In the interest of time, I'm just going to write out the names for these. Check it against what you have. And if you have questions, then you can go for it. So ClO3, that is the chlorate ion. The rules for that is you get rid of the 8, you write ick, get rid of ion, and write acid. So your first one should be chloric acid. Your second one, it's a binary acid. So you start with hydro. Your non-metal here is bromine. So we're going to keep that first syllable. Get rid of everything else. Follow that up with the ick and the word acid. Try to keep consistent with how I did it. So you should have hydrobromic acid for that second one. The third one, so the first one is a ternary oxyacid. So we don't use hydro for those. For those, you start with the name of the oxyanion, and then you use either ick or us at the end. So hydro is only for the binary acids. So let's do another one of the ternary oxyacids. You look up that ion, you'll find that it's the sulfite ion. The rules for that, you get rid of the ITE, replace it with OUS. Get rid of the ion and write the word acid. So your answer should be sulfous acid. You may, if you take more chemistry or you do any kind of lab work or anything like that, come across an alternate spelling with a PH instead of the F. Same thing. Do we have questions, or are we good to move on? Alrighty. So I've got some more practice for you. Let's take 3 minutes, classify each of these, and write out the chemical formula. So this will give you some practice with writing the chemical formulas for some of the ones that we did not cover. I'll check back in 3 minutes. Alrighty. So again, I'm going to go ahead and write out what the answers are, and then you can ask questions along the way. Iron 2 oxide. To classify it, looks like we've got one metal plus one non-metal. The only thing it can be is a binary ionic compound. Writing the chemical formula, we can directly translate that iron 2 part. The oxide, we got to do a little bit more work on. So that comes from oxygen. Which is in group 6A. We find its charge by taking the group number and subtracting 8. That gives us -2. So that's our anion. When we add them together, we get 0. We've got +2 and -2 when we look at our charges. So that's the chemical formula. And again, it's a binary ionic compound. Questions about that one, or are we good? And I apologize. I don't think we took a break. But you can see that we are coming up on the wire for time. It's really difficult to fit in an entire chapter and questions and examples in one session like this. So I appreciate y'all. I know this ain't easy. It ain't easy for me either. I'm pregnant. Sitting down for this long, this far along, it don't do me no good. So if you had my camera on, you would see I'm trying to stretch and do all the things while you're taking 2 minutes to do these examples. So again, I really thank you for your participation the whole time. Let's move on to this second one. Phosphorus trichloride. Just from seeing the way that this is named, we've got the tri. That clues you in that it's a binary molecular compound. You can also see that we've got phosphorus and something about chlor, which clues you into chlorine. So there are 2 non-metals here. And again, that's a binary molecular compound. To go backwards from the name to the chemical formula, you look at what the element is and what the prefix is. The first word is phosphorus. The symbol for that is a P. There is no prefix, so there's only one. Then we move on to the second word, trichloride. The chlor tells you that it comes from chlorine. So we're going to put Cl. Tri tells you that there are 3 chlorine atoms. So you write the subscript 3 for the chlorine. How do we feel about that one? Because that's an example of something that we did not do an example of back with when we did this. Okay, I was hoping it was easy enough to where you could go back and forth. Now we've got this last one, calcium phosphate. Calcium is a metal. Phosphate is a polyatomic anion. So it's got to be a ternary ionic compound. We've gone over the calcium ion quite a few times, so I'm just going to skip to the end for that one. So that's our cation. Phosphate, you're going to look up. As you do more practice with these, you might even start to remember some of them. That's okay. When we total up our charges, we can clearly see we're not getting 0 there. If we had 1 calcium ion and 1 phosphate ion, we would not have 0 as our net charge. So we've got to do the cross thing. No problem. So that would be our final answer. Any questions on that one? That's all I have. I've got some reminders for you. You've got a Chapter 6 check-in and Mastering Chemistry. All of that is due on Sunday. The chapter check-in It's a total of 6 questions. 3 of them you classify and you write the name. The other 3 you classify and write the chemical formula. If you can't get that done inside of like 15 minutes, then you should definitely reach out to me. If you take the time to go through the lectures and practice, that chapter check-in should not take you long at all. If it does, then the mastering chemistry is going to be struggle bus. So if you need help, make sure that you look over the homework tonight, even if you don't do it, and then come see me in office hours tomorrow between 2 and 4. Your 3rd exam is next week. It will be on chapters 5 and 6, which is why I'm urging you to do your mastering chemistry homework and the chapter check-in. The chapter check-in is the only way that I have to give you individualized feedback, so I can take a quick look at them when you submit them and address kind of the overall issues that people had. So make sure that you do that and get it in, so that Tuesday we do exam review and we move on to chapter 7. The final thing I want to bring up, so the practice exam for exam 3, no, the worksheet, if I didn't put it up there, I'm going to put it up there right away. I have it for my other section, so it's just a matter of transferring it over. So I will put up the practice worksheet for chapter 6 right after this class. I will have to prepare the answer key, so that's not going to be posted right away. But I will also post an exam 3 review, just like all the other exams. So this is going to be the 3rd exam. It's going to be the same exact thing. You get the exam, periodic table, and any other information that I give you in that folder, you can print out and use. The final thing, very quickly, some of y'all are still sending me emails, and I know that's how we normally do things. However, we need to use Blackboard course messages. Course messages is under communication on that sidebar there if you're going to it online. I don't know what it looks like on the app, so I'm sorry. You click on that, then you click on create new message. It's going to bring you to a page where you see something like that. Click on this one, the 2, and it's going to give you a drop-down menu of all the people in the class that you can send a message to. If you want to message me, you should choose me. That's me. Hooray. Once you do that, there's a button that looks like this. You need to click that button to add me to the recipients list. Once you do that, you can put in your message and attachments, whatever you got to do, and send me a message through Blackboard. I check it multiple times a day, Monday through Friday, 9 to 5. If you message me outside of that time, I may not see it. So if you message me on the weekend, on Saturday, asking me something about mastering chemistry due Sunday, I may not see it to help you. So just keep that in mind. That's all I have for y'all. If you have any questions, feel free to stay and ask. Otherwise, y'all enjoy the rest of your day. Thank you again.